हे गाइस, सो आज के वीडियो में हम लोग डिस्कस करने वाले हैं लिंक्ड लिस्ट के बारे में, राइट? सो व्हाट इज अ लिंक्ड लिस्ट? लिंक्ड लिस्ट इज एन एग्जांपल ऑफ डेटा स्ट्रक्चर, राइट? एंड इट इज एन एब्स्ट्रैक्ट डेटा टाइप। एब्स्ट्रैक्ट डेटा टाइप का मतलब क्या होता है? जिसे जो डिफाइन करता है डेटा टाइप को उसके बिहेवियर से, राइट? और एंड लिंक्ड लिस्ट इज अ कलेक्शन ऑफ ऑब्जेक्ट्स और नोड्स that are stored randomly in memory. That are stored randomly, right? For example, suppose I have an array in my memory, right? Suppose from here I am starting my address. Right. Now suppose I have an array 3, 2, 1. So my array will be stored in a continuous location like this 3, 2, 1. But if I want to store a number here and I don't know how much space to allocate, right? And then I want to store a number 6, suppose here, and then I want to store a number randomly, suppose here. So how can I access the other number by using the first number? So what I will do, I will store in the next of, I will prepare an object or node which will contain the address of the other element, the second element that I want to point, right? So this will store the address of this number, and this node will store the address of this number, right? And this will store null, because storing null means my linked list, which is collection of nodes, has ended, right? So this will be like this, right? Now let's define a node. Suppose this is my node, right? So a node has two parts, data part and link part, right? Now a head will point to a node, right? First node, and the data part will contain the value. The link part will contain the address which will point to the next node, right? And again this will contain a value. And then if it is my last node to store, here I will store null, which is also called as tail, and this is end of list, right? Now we will discuss about differences between array and linked list, right? So I am telling you first differences, then I will explain how these differences are मतलब इन differences को I will explain through diagram, right? So first difference is array size of array is fixed, right? You have to declare size for array at compile time only, right? But for linked list you can change the size during runtime, right? So linked list has dynamic size. Now for inserting a new element, order of by shifting, right? Suppose in array I want to store a new element. Suppose here I want to store a new element, suppose 6. Then I will shift this element to the right and this element to here. So I will do my shifting using for loop, right? And then I will insert my element. So this will take time complexity. Insertion in array will take time complexity of order of n. Now in linked list. Suppose I want to store in linked list. Suppose I want to insert a node here. So what I have to do, I have to first access my head, then I will access second. I have to traverse my first node and then second node. So this will also take time complexity of order of n. Now one difference is that for beginning, if I want to insert an element at beginning, I have to shift my all elements to the next. So this will take time complexity of order of n. But I have to store a node in beginning. It will take only constant time. Why? Because I have to simply change my head part. So my head will point to my first node, which is my new node, and that will point to this node. So it will take constant time, right? No need for any for loop, right? And if at end I want to store, it will take time complexity of 1 only, because I don't have to perform shifting. No shifting is required. Simply I will insert my value here. But for inserting a value in end of a linked list, I have to traverse all my nodes or objects. So it will take time complexity of order of n, right? This is what we discussed. Now, random access is possible. Suppose I have to access my element in the array at index 1. So I will simply access it using writing the index, right? Array name and index. I will be able to access my element, and the address I will access here is base address plus index into size of data type. In case here it is integer, right? Now random access is not allowed, is not possible in linked list, because for accessing any node you have to traverse once. You have to access first every node, then you will be able to access the node where you want to go, right? Now binary search and linear search is not, sorry, linear search is possible in array as well as linked list, but binary search is not possible in linked list, because you can't be able to first go to the middle of the linked list, right? For that you have to traverse, you have to perform traversal. But in array you can access any element. You can begin with accessing any element in your for loop, right? Now code, we will be discussing about code, right? Suppose this is my node and here it is value and here it is my address, right? And address of this node is 102. The size allocated to memory for this node will be 4 plus 4, 8 bytes, and my code will be like this, right? I will write here first struct, this is my data type for node, name of node, right? And I will declare my variable, and then I will declare my pointer, the next part, the link part, this is my data part, node, start, next, right? This will be my next, right? This is my code for representing a node, right? So I am erasing this. Right. Now we will discuss about type of linked list. So first we will discuss about singly linked list. Now in singly linked list, one node will singly link to its next node, right? It cannot link to its previous node, only to its next node. Only forward traversal is possible. So singly linked list. Right. Suppose this is my head, which will point to the first node. Right. It has value, it has its own address, and the next part will point to the next node. Right. It has also its own value, own address, and the next part will point to the my next node. Right. And here it is null, determining the end of the linked list. Right. Now representation is the simple that I have discussed here. Now in doubly linked list, each node has three parts, right? In middle data, one pointer to point for previous node and second pointer to point for next node. Now suppose this is my head pointing to my first node. Right. Now what is happening here? This is address of my second node. This is address of my third node, right? But this is address of my previous node, and this is address of my first node. So what is happening? Basically, each node can point to its previous and next node, right? The representation of doubly linked list can be written as, again, a struct node my data type and declaration of data, right? A struct node next struct node previous, right? Now this part will store address of my next node, right? And this part will store address of my this part will store address of my previous node, right? And then we will discuss about singly circular linked list. Singly circular linked list. This is simply the singly linked list, but in this case what I will make changes, I will in my last node, my last node will point towards my first node. So here I will store 100 and this will point towards first node. Similarly, in doubly circular linked list, what will happen? My last node will contain address of will point to the first node, and my first node will point to the last node. So it will contain the address of my last node, right? This was all types of linked list. Now next we will discuss in our next video.